Right, welcome to my second video on understanding compound angles, reduction formulae, but basically with the intent of helping you become more familiar with the unit circle. So let's get started. Remember, we're using a specific triangle here. We're using a 30, 60, 90-degree triangle, and the hypotenuse of this special triangle to the shorter side is 1, the longer side is √3. I know it doesn't look like this is not drawn to scale. Many times in high school they'll actually on purpose cheat you. They won't draw things to scale just to annoy you. I'm generally not one of them. Maybe I'm just bad at drawing. Anyway, so basically our triangle looks like this. Okay, so we have our 30-degree angle here. We have our √3 over here. This is 1, and this is 2, and this is our 60. Now, again, let me write this down real quick. So the sine of 30 is opposite of our hypotenuse. It's a half. Cos of 30, well, adjacent over hypotenuse, √3 over 2, and tan of 30 is opposite over adjacent, 1 on √3. Okay, so now what if I want the sine, cos, and tan of, let's say, 180 plus theta, or in this case 180 plus 30. How would we go about that? Let's have a look at what this looks like. First of all, this is obviously our, let me take a different color. This is obviously 180 degrees, right? So this angle is going to move up from here 180 degrees to about here. So our triangle that we're going to work with is going to look like this. And again, don't draw a triangle like that. That's not going to give you the right answer. This is going to give you the right answer. So here's your 30-degree angle. 30-degree angle over there. Now, remember that previously our triangle we worked with looked more like this, but we had the 60-degree angle over here and the 30 here. I hope it's clear because this was the sine of 90 plus theta, or 90 plus 30. I hope it's clear to you that this is 180 plus 30, so this is going to be a 30-degree. Starting here, 180 plus another 30 degrees. Let me remove all this so we can work with a clean slate here. Obviously our 60 is over here. This is our 2 still, and by 30 and 60 I obviously mean degrees. Next to the 60, this is our 1. But what is this? This is very, very important. Don't get this wrong. Let me circle this 3 times for emphasis. Don't say 1. This is -1 value. And the same with this, right? This is a -√3 value. So, what is this infamous sine 180 plus 30? Well, now we can work it out. Opposite over hypotenuse. But this opposite's -1, so it's -1 over 2. The cos of 180 plus 30, what is that? Well, adjacent over hypotenuse, minus √3 over 2. And then tan of 180 plus 30 is opposite over adjacent, -1 over -√3. -1 over -√3. And one desire of my heart at this very moment is that you would experience the joy of realizing why in our cost diagram tan here is positive. Tan is positive because we notice that the opposite and the adjacent are both negative. Negative divided by a negative is a positive. So I hope this dawns on you as a wonderful revelation, understanding why tan is actually positive in this quadrant. But I hope that makes sense. That to me is quite interesting. Let's do another one. Maybe a little bit more difficult. And for the purpose of fun, I'm going to do this in purple. What if I wanted the sine of, let's do a negative. Theta minus 90. Yeah, theta is minus 90. Now, obviously, we're not working with. You could really redo this entire exercise using, theta, and get these with respect to theta and like an x and an r and variables. But we're not doing that for the purpose of this demonstration. So let's see. 30 minus 90. 30 minus 90. Now again, that's your theta minus 90. You could generalize these statements. What would that be, and what would be our cos? Obviously, 30 minus 90. Again, please forgive my not adding degree signs. I assume that you understand 30 here means 30 degrees, right? Okay. Point being, so what would that look like? 30 minus 90. Well, we know that if this was nothing, right? If it was 0 degrees, minus 90 would be on this axis right here, the y-axis. So 30 minus 90, that's minus 60, right? So if we had to minus 90 from here, if we had a minus 90, we'll minus a 30, right? Minus another 30, obviously. Now we're at minus 60, minus another 30. We're at minus 90. So, 30 minus 90. So we're going to add, it's going to look like this. But what angle's going to be over here? What angle is going to be over here? That's the million-dollar question, actually. It's really the biggest question here. This is going to be your 60, and I hope that makes sense to you. I really do. Obviously, this amount here is going to be 30, because when you take this 30, you subtract 90 from it, from this point, you're going to get at negative 60. So that's the same as asking the sine of negative 60, right? So let's quickly work that out. Let's see, what does this look like? So our hypotenuse is 2. Our adjacent over here is not root 3 anymore. Our adjacent over here is 1. Our opposite here is root 3. Very important. Don't get this wrong. Now, where was I wrong? This isn't root 3. This is negative root 3. Very important. Very important. Okay. So, let's look at our sine. Sine is opposite of our hypotenuse. So it's negative root 3 over 2. Cos is adjacent of our hypotenuse, which is just a half. And our tan is opposite over adjacent. So it's a negative root 3 over 1. So it's negative root 3. Okay. I hope I've made sense today. I really do. So just to recap, to admonish, to encourage 2 things. Remember that when we minus 90, this triangle really does swap around. That's 60, not 30. That's mistake number 1. Mistake number 2 is to get these signs wrong. And they will really cause your calculations to be totally off base. So I hope this helped you today. And if you have any questions, please do write a comment in YouTube. If this helped you, let me know. I certainly do not wish to waste your time and mine. So have a good day. I'll see you in the future.